Hello and welcome to the OTB channel. Have you ever been asked the question, exactly how does the internet work? And you've stumbled a little bit. We all know that the first stage for us as desktop users is making sure that our computer is connected to our router wirelessly or by wires. The router connects to our ISP and suddenly the magic happens. And if we want to access a website or some other part of the internet, it just appears. How does it actually do that? Do you know the details, the magic between the computer and the internet? I'm betting that most people don't, because it's one of those vague areas that can get really technical, especially when you start to touch on DNS. So this video is going to be pretty much a non-technical primer, a little bit of a DNS 101 for the rest of us. So let's discuss after the intro. Okay, and welcome back. Right, DNS. Years ago, I used to have a t-shirt. Many of you know that I like my t-shirts. And it had a funny graphic on it. And it had a picture of a computer. And then it had the word internet with a cloud drawn around it. And then it had a big circle in the middle between your computer and the internet. And it just said magic. And for most people, I really do think that holds an element of truth. We know that when we're trying to access a web page, we know that the web page is actually installed on somebody's server somewhere in the world. We know that we're connected to our ISP, and we know that the internet allows us to access that server wherever it may happen to be. But as for the details of how it does that, well, many of us are quite vague, including me. I used to work in IT, and I used to work for a DNS server company, but I wasn't one of the techies, so my understanding of it is very much a layman's understanding. And so this video really isn't going to be a hugely technical video. It's going to simply be about the basics of DNS, which can actually be important because understanding just the basics of DNS can help you troubleshoot internet problems on your computer. They could help you speed up your connection. They could improve the security of your internet connection. And in some cases, by changing your DNS provider, you could also gain a number of perks, such as website filtering pages, which can be particularly useful if you have kids. So let's just talk about what DNS is in its basic form. When we access a web page from our computers, we put in the name of the site, whether that be www.google.co.uk or Facebook or archlinux.org, whatever the host name is that we're trying to access. And our computer just magically returns the web page. Now that's pretty amazing, really, because the internet does not really understand human readable terms such as google.com or archlinux.org. The internet works with IP numbers. Now, you've probably seen IP numbers, 192.168.1.200 or whatever. So what actually has to happen in order for your web page to show the results of google.com, your search for google.com, is it has to go out to something called a DNS server, the domain name service, and the domain name service acts almost like a telephone directory. And it looks up your query, google.com, and it comes back with, yes, This is the IP address that you want to access, comes back to your computer, and suddenly the web page opens. So let's just go to the split screen and let's expand upon that. Well, you should see the slide in front of you now. What does DNS do? And I perhaps should have described this video as DNS in a nutshell, because many of the techies out there will be saying, whoa, it does far more than that. But at a basic level, we have something out there called a domain name service. And essentially, it's the backbone of the internet. The internet, as we know it, just wouldn't work the way it does without DNS. And its main job is to resolve, that's an important word with DNS, to resolve a human readable address such as google.com into an IP address that your computer can understand. So in that sense, it's often thought of, as I've just said, almost like a telephone directory. We put it, because we're never going to remember all the numbers of the websites that we access on a regular basis. So it's much easier for us to just feed in a human readable name and let the DNS service out there do its thing and suddenly just present back the web page to us. But how does it actually do this? How does this magic happen? Well, how the magic happens on the surface is really complicated, with a whole range of different steps. But what's even more amazing, is the fact that all of these steps take milliseconds to happen. They happen behind the scenes. So, the DNS system, try and think of it as a set of hierarchically organized servers that are out there. And the first step when you put in a request through your browser to access a website and you're using a human readable host name is that your computer will go off to something called a recursive resolver. Now, by default, you won't have to set this up. Your router will automatically go out and use your ISP's DNS resolver. Automatically. You can use a third party. You're not tied to your ISP's DNS resolver, but I think it would be fair to say that most people tend to just accept the defaults, if they're even aware of it. So it goes off to the resolver and it says, okay, we want to access this page. Can you return the IP address to us, please? Well, the question here is, it might be able to do that straight away. And it might be able to do that straight away if there's been many requests for the same web page and it's managed to cache the information for what the IP address is. And if that's the case, great, it can return the IP address straight back to you. If not, though, your ISP's recursive resolver will go out to what's called a root server. Now, there are 13 sets of root servers around the world. That doesn't just mean 13 computers, but sets is the way to think about it. And these high-level servers deal with the top-level domain names, such as .com, .net, .org, etc., etc. And the root server, in turn, will then pass on details of what's called a top-level domain server. The top-level domain server will have the first part of that human readable name. So your root server will deal with the .com part. Your top-level domain will deal with the Google part, if you like. From there, the top-level domain will pass on details of an authoritative name server. And the authoritative name server is the server where the web page, well, it's not where the web page is actually stored, but it's the primary server that contains details of the IP address for the particular web page that you want to access. And that is eventually passed back to your recursive resolver, your ISP's recursive resolver, and hey-ho, the web page appears in your browser. Now, as I say, those multiple steps are only necessary if the website isn't cached at particular stages. And it could be cached in your browser, so your browser doesn't even need to go off and go to the internet to query a DNS server. Your operating system might have a cache of the information that's being required, and your recursive resolver could have that cache as well. But technically, if the cache doesn't exist, it will go through all these various steps. So Cloudflare, I noticed on their website, I've got a really useful diagram that can help us understand that in a little bit more detail. So you should see the diagram now in front of you, courtesy of Cloudflare, and I think it's quite useful to understand. Here you have your computer, and this is trying to access something called example.com. So there's 10 potential stages that initial query is going to generate. From your computer that's trying to access example.com, you're first of all going to go off to your DNS resolver, probably your ISP's DNS resolver, but doesn't necessarily have to be. If your recursive resolver already has that information cached, well, that's great. It'll just return it to you. But if not, the recursive resolver is going to go off to a root server, which deals with the .com part of example.com. Your root server will then pass back details of the relevant top-level domain server that your DNS resolver needs to access. So it goes from you to your resolver, from the resolver to the root server, from the root server back to the resolver. Then the resolver goes off and makes the request to the TLD server, which returns an answer back to the DNS resolver, which then queries the authoritative DNS server for example.com. Example.com passes back the IP address for example.com to your DNS resolver, which is in turn passed back to your computer. Your computer now has the information it needs to access that website, so it uses the IP address to contact the server, and the web page is returned. So just to give you an example of why IP addresses are so important, you'll see Firefox in front of you, and if I type https://archlinux.org, there we go. We get the archlinux.org page. However, I can equally put in the IP address. Because this is an HTTP address, I need to put that part in. And then I would just put in the IP number, which in this case I know to be 138.201.81.199, and visit that IP address. Straight away, it goes to Arch Linux. It resolves it to that. So you can put an IP address directly into your browser. Sometimes the way that browsers work, because a security certificate won't immediately be visible to your browser when accessing a website just with an IP address, you may get a warning. But essentially, this is how it works. Right, so an IP address is ultimately what we're trying to get hold of. How do we get that IP address? Well, it's all done by the DNS server process. But actually, there are a number of tools that whatever computer platform you're running will allow you to resolve a host name into an IP address. Most Linux users use a tool called dig. It's normally installable through the bind utilities package or bind tools package or something similar. And it can be installed on on Windows as well, but dig is our sort of native tool. We then have NSLookup, which traditionally has been the Windows DNS tool. It's available on Linux as well, and for many years, whenever NSLookup was used, we used to get a message that says it's deprecated. That seems to have disappeared now. And for a very basic lookup on Linux, we can use the tool host. So which one you use is ultimately up to yourself, but actually the syntax is pretty similar. Let me just show you. So you should see in front of you my terminal now. I'll just make that command prompt a little bit bigger so you can see it. If we wanted to use it to look up the IP address of a particular host, let's use archlinux.org as an example, and we use the dig command. We would just type dig. As a normal user, you don't need to be a super user, archlinux.org, and we would get this output. Essentially, breaking it down into its basics, it repeats the question that we've asked. Look up the A record, in other words, the address, A stands for address, of archlinux.org, and it returns the answer to us with the IP address for archlinux.org, which is 138.201.81.199, and it tells us how long that query took, 20 milliseconds. We could also use the host command. So host archlinux.org. That gives us a much simpler output, but essentially gives us the IPv4 and the IPv6 address, which is absolutely great. So same answer there, 138.201.81.199. And if you're on Windows, you'd use NSLOOKUP. And again, just put in archlinux.org and you get essentially the same. So the address is 138.201.81.999, should I say, and the IPv6 address as well. You'll see it says the non-authoritative answer. What that essentially means is it hasn't received that IP address back from the authoritative server. It's managed to pick up the answer before it's got to that point. If you wanted to have a look at all the steps that dig actually took in order to resolve the address, that's easy as well. You just put dig plus trace archlinux.org. And it's working now, and it's coming up with the particular steps that it's had to go through. So let me just make that smaller so that you can see. So it's not just a simple to one server and back situation. Let's just clear that. Right. The other thing that we can actually do with dig, which can be quite useful, by default, it's going to use whatever your default DNS server is for your ISP or the one that you've set up on your computer, but you can get it to use a different DNS server. So let's, for instance, use Google's DNS server to do that same lookup, and we'd still do dig, but we'd use the @ command followed by the IP of Google's DNS server, which is 8888, and archlinux.org. There we go. So that was an exercise in what we can do if we want to. But why is it important to just understand a little bit about DNS? Well, as a first stage, sometimes we all lose our internet connection, or we think we've lost our internet connection. As a first step to see if that's really happened, the best and simplest test is simply open a terminal and try and ping a domain name. So ping archlinux.org and see if you get a response. If you don't get a response, try pinging an IP address. I would normally ping 8888 because that's the one I remember, the Google DNS server IP address. And if I do get a response from the IP ping, I know that I am still connected to the internet. It's just that for some reason, I'm not currently able to resolve a host name to an IP address. This could be for a whole range of reasons. It could be that my DNS server has gone down or there's something wrong with it. And it can quite often be very simply resolved by just changing your DNS server. So let's talk about that. By default, the routers that people use that are supplied by ISPs will generally use your default DNS server associated with your ISP. On the vast majority of routers, though, if you log in as an administrator, you can change that yourself, and you can put in your own name servers. And there's lots of them out there. There's OpenDNS, which just comes to mind immediately. There's Cloudflare, there's Google, and any number of other free public DNSs. So you can change that. And if you change it in your router, it will affect every device that is on your network. And in fact, if you look on a Linux system, for instance, at what your DNS server actually is, most of the time it will be pointing to your router, not pointing to an external DNS server. But you can configure that and change it. So how do we actually change it? Well, let's go back to the terminal here. On a Linux system, your DNS resolvers are actually saved in a file called resolve.conf in the etc directory. And you'll see at the moment, mine are actually showing two name servers, 1.1.1.1 and 1.0.0.1. Now, I've configured this myself. Prior to me configuring this myself, the name server that was initially here was simply the IP address of my router, which was 192.168.1.254. I didn't want to use the DNS resolver for my ISP, so I changed it to some custom numbers. Now, I could do this on the router itself. It's not brilliantly easy to do so with the router that's been supplied by my ISP, so I just change it on individual machines. But it's easy to do either way. Do you actually edit etc resolve.conf yourself? Well, actually, rarely. Normally, what you would do on Linux is you would go into, let me think, network, advanced network configuration. This is part of the network manager package. If I click on my wired connection and go to settings and IPv4, you can actually see that down here, I've set those DNS server settings, 1111 and 1001 in there. I've set the method not to DHCP, but to DHCP addresses only. So it won't use the default ISP DNS address, and I've simply saved it. And that has saved to etc resolve.conf. It's as simple as that. So changing your default DNS server that your computer's using is a pretty trivial matter. And there's a number of reasons why you may want to do that. The most obvious one is you keep having DNS problems and your internet is being very, very slow, or you're having problems resolving host names. But there are other reasons as well. And let's just go back to the slide. Certainly, there are going to be possible speed improvements by changing your DNS provider. Now, I say possible. There's a whole range of variables come into this, because you could use a particular DNS provider that's really fast for somebody in a particular part of the country, but in the geographical location where you're situated, there might be quite a distance between you and the server, and so it's not going to be as fast as you'd hoped. And there's a whole other range of variables come into force that can affect the speed. There's also a question of reliability. If your ISP's DNS server seems particularly unreliable, well, you might be better swapping out. And there's also the issue of better security. Certainly the big public ISP providers such as Cloudflare, that's it, Google and OpenDNS have very, very good security, and it might actually be better than your ISPs. In some cases, you might even be able to bypass any sort of web blocking that your ISP implements. This doesn't mean changing your changing your DNS server will automatically allow you to access torrent sites that were previously blocked. But there are some DNS companies out there who will allow you to do that, although they tend not to be free. Sometimes, though, and this is something I use when my children, I have 3 lads, when my children were very small, they were all into computers, and I was quite concerned that they didn't access inappropriate content. Now, you can go out there and you can buy all sorts of software that add parental controls, but a very simple way to monitor, or not monitor, to manage what your kids are able to watch is by using a company such as OpenDNS. You create a free account, and they actually have a console where you can choose which type of websites are blocked. I'm sure you can imagine which types of websites you would block 8, 9 and 10-year-old lads from accessing, and it worked really well for me. You can even customize it with your own logo, the face of dad going no. So that was really useful. And there's lots of choices out there. But which DNS provider should you choose if you're not going to stick with your default ISP provider? Well, clearly, if you want something like website filtering, that's going to skew your choices. And I'd personally recommend OpenDNS. They're very good. But if it's just about speed, well, it's no good just doing a couple of queries. You're going to have to run some sort of benchmarking tests to find out from your location which DNS servers are going to be best for you. And luckily, there are a number of applications that can help you do this. In Linux, one of the utilities that can be used is something called DNSBench. And you can see that on the screen now. I know within Linux it's available in the AUR. And you'd simply set your name servers that you want to query, tick the box there to include the main DNS providers, include the best available regional DNS services, and you link it to which browser you want it to use as an example to go off and do a query of the websites that you access all the time. Or you choose, top 2,000 websites, etc., etc. Decide how many queries you want it to do, and you hit Start Benchmark. And it takes quite a while to go through. Once it's gone through, though, it outputs the results to a web page. And this is just a web page opening up automatically in my browser that you can see now. And after running the test, it's come up that my DNS server is actually the fastest, which is great to know. Right, another tool that you can use to help you, and if I just shut this down now, is a tool that's more for Windows than anything else, and it's called DNSBench. Now, I'm running this on Linux because it runs fine with Wine. I'm using it with CodeWeaver's Crossover Office. Really simple to set up, and you'll simply select the name servers tab, click on what you want to focus on, and I want to focus on response time, so I'll let it do its thing, and then I hit Run Benchmark. I'm going to hit Run Benchmark, and we'll come back in a minute once it's done, because again, it takes a while. And we've now finished the DNS benchmark. It doesn't display great in Linux, to be honest. It's much better, I'm sure, on Windows. But it actually shows you a graphical representation of the fastest DNS servers for you from the geographical location where you're making the requests from. And I'm actually coming from this one, 1111, Cloudflare. And you can see up there, it's actually pretty good. I mean, yes, there are faster ones there. I'm not exactly sure where they are, so I'd prefer to go with a known name. But it looks like Cloudflare is pretty much getting it right. If we go all the way down, you'll see that we've got Google's DNS servers there that appear to be a lot slower than Cloudflare's. And I think we've got here OpenDNS web servers that are pretty quick as well. So There are ways that you can benchmark your DNS in order to choose which DNS provider that you're going with. And in the information down below this video, I will provide links to both DNS Benchmark and also to Namebench. So the bottom line here is, if you're having problems with your DNS, or you're interested in finding out if a particular DNS server is going to give you a faster connection, well, run some benchmarks. And if you find a faster DNS server, either configure the server's IP addresses in your router so that all machines can access it, or alternatively, configure it device by device. Now, it wouldn't be right finishing this quick 101 on DNS without talking very briefly about something called Dynamic DNS. So, Dynamic DNS, what is it? Well, let's start off from the assumption that you need to access the network at your home address or business when you're out and about, when you're working remotely. The problem is, for most of us, we don't have a static IP address. If you want a static IP address, most ISPs will give you one, but you have to pay for the privilege and they can be quite expensive. But there is a solution. If you want to connect to your home remotely, or perhaps you want to run a home web server, how do you do that without buying a static IP address? Well, you sign up for a Dynamic DNS account. And what this gives you is it gives you a host name. Most Dynamic DNS providers have a range of free host names that you can use, linked to their own, and they match it with your IP address. Now, how does that stay up to date? Well, it stays up to date in a number of ways. You can access it on the web every now and then just to update it, but it's much easier if you just download a tool on your computer that constantly communicates with the Dynamic DNS provider and lets it know when your IP changes. In many modern routers, you don't even need to do that. You can set Dynamic DNS up in your router and set it up so that it contacts the likes of NoIP, who are a Dynamic DNS provider that I've used before that are pretty reliable, and it does it automatically and you never have to think about it. Many of these providers do offer free accounts. With free accounts, there's always some provisos. So with the NoIP account, you have to renew your account every 30 days just by logging in and clicking on a link, and they do send you a reminder by email. But other than that, I've found it to be pretty reliable. Right, so that was a bit of a run through, and we've only scratched the surface, really. But hopefully this has given you a little bit of an overview of just how important DNS is. And if you've never explored whether or not another DNS provider might be faster for you and improve your internet connectivity, you've nothing to lose by at least having a look, running a few benchmarks, and then changing the settings on your router or on your computer. So that's it for now. I hope you enjoyed this video. Just as an aside, please join me on Library, and as well as my Facebook group, this week I've also got a subreddit, so our OldTechBloke. So by all means, come and have a look. Enjoy your weekend, everyone. Thanks very much for watching.